So hello everyone and welcome to this Clara project webinar series. And so today we're going to be talking about a webinar that is entitled Climate Services for Irrigation Agriculture, WRI and IRRICLIME. And so this is the third webinar of this series. So in total we have 6 of them. We'll be having another 3 after this one. So before we start talking a little bit more in depth about the webinar, I'd just like to talk a little few words about the CMCC, who is hosting this webinar series. So CMCC is a research foundation based in Italy, and the mission of CMCC is to investigate the climate system, so how the climate system interacts with the society, with the environment, and how these interactions can evolve in the future under climate change. So we'll talk a little bit about adaptation and mitigation policies and so on. CMCC has a network of 7 different. It's located in 7 different cities around Italy. So, for instance, the one that I'm based here is in Venice, but we have another offices like in Milano, Bologna, Viterbo, Capua, Lecce, and Sassari. We're structured into 9 different research divisions. For instance, in Venice, where I'm based, we have the risk assessment and adaptation strategies division, and also the economic analysis of climate impacts and policy. We have these 2 divisions here in Venice, and other divisions that you can see also here on the screen are also located in other places around Italy. The topics that we touch, they range between a broad range of let's say, research topics and that we touch. So, for instance, we touch a little bit about modeling, policy, adaptation, agriculture, society, and one that is very interesting and is very pertinent to this webinar here of today is services. So, because the Clara project that is actually holding this webinar series is responsible for development of different types of climate services. So we also develop this kind of research here in CMCC. If you're interested in following what we're doing here, you can take a look, of course, in scientific publications that we made available through scientific journals. You can also take a look on some of our events and education programs that we're organizing around, and also on the communication side. So this is pretty interesting. We have like the YouTube channel, Facebook channel. This is a very easy communication that we have with people that are interested in following our development and so on. And particularly about this webinar here is going to be recorded, and you can see the recording later on also on the YouTube channel and also on the Clara website. Both of the links are shared here on the screen, so you can take a look and follow that. And you can also take a look on the Clara webpage on Facebook by take a look on the link that is also provided here on the screen. If you have any particular question about this webinar, you can also send an email to this email that is shown here, so webinar@cmcc.it. And just taking this chance also just to say which is going to be the next CMCC webinar, also part of the Clara webinar series, is on energy and climate, seasonal forecast for energy production. So this is going to be next 19th of November at the same time. And I pass now the floor to Vittorio Marletto, so he can introduce a little bit better the webinar of today. And thank you.
Okay, I hope you can hear me. This is Vittorio Marletto speaking from Bologna, Emilia Romagna. I am working at Arpae, the regional environmental agency of Emilia Romagna. We are partners of the Clara project. Clara project is supported by the European Union through the Horizon 2020 research and development program. And this is the 3rd seminar in a series of webinars that we are carrying out because we want to show as much as possible what we did in the field of climate services. Climate services, specifically today, you will hear about climate services devoted to agriculture. And most of our agriculture is irrigated agriculture, so they are both devoted to irrigation. And I would like also to underline that both services have been developed mainly by partners from Emilia-Romagna. You will first hear about Water Resources of Irrigation Climate Service, WRI as an acronym, from Giulia Villani, a colleague of mine, PhD in agriculture and specialized in irrigation science. And the other service will be illustrated by Stefano Bagli, engineer, and he's from a private company, GECOSistema, based always again in Emilia-Romagna, but in the city of Cesena. Both services are relying on the existence of a water balance model called the criteria in Italian, or criteria in English. It was developed here at Arpae, and it is available to all developers who want to use it to build products on this model in several versions. Again, I would like to stress that this is one webinar from a series, and next Tuesday there will be another one devoted to climate services applied to the energy sector. But now it's time to give the microphone to Giulia Villani, who will illustrate the WRI, Water Resources of Irrigation, and I turn my micro off. Thank you.
Okay. I hope you can hear me. Good morning, everybody. I'm Giulia Villani. Thank you, Vittorio, for the introduction. In this presentation, I will present in detail the climate service WRI that Vittorio mentioned, that has been developed here in Arpae, Emilia-Romagna, within the Clara project. First of all, some basic information about the climate service. WRI is a tool conceived to support all the organizations or the authorities that manage water for agriculture. So in Italian, they are called Consorzi di Bonifica, so we'll speak about Consorzi di Bonifica, but if we translate this word in English, it's the name is Land Reclamation and Irrigation Consortium. So how WRI support these water managers in agriculture? It provides a support in the water procurement and water allocation. In other terms, its aim is to increase the efficiency of water distribution, and as a consequence also energy consumption, because when we talk about water for irrigation, we talk about also energy to pump up this water. So going through in more detail to the WRI, this climate service provides information about crop water needs, and this information are basically forecast. And WRI provide forecast of two types. Seasonal forecast, so the service each month provides 3-month forecast of crop water needs, and 7-day forecast. This is the second group of product. So the service provides each day the forecast of crop water needs for the following 7 days. For specific areas. We will see in the next slide how this information are displayed and in more details each product. The result of WRI, so this forecast, this information about crop water needs are the result of a complex methodology that includes the weather and seasonal forecast that I have mentioned before, And then the calculation, the computation of crop water needs is computed by a soil water balance model that Vittorio mentioned before, criteria 1D. The third and crucial element of this operational chain is a crop map, because the forecast of crop water needs rely on this crop map that is obtained by means of analysis of remote sensing data, basically at the beginning of the irrigation season. Basically at the beginning of the irrigation season in April, there is an analysis of 3 satellite images that provide this map. And this map is a classification of crops that identifies where crops are irrigated or not irrigated. Basically the service starts in April and ends in September. The most water demanding period for Emilia-Romagna is summer, so June, July and August, but the users that manage water and agriculture are also interested on details of this period, so the beginning and the end of the irrigation season, because in these periods water crisis due to, for instance, drought can occur. The service has been applied in 2 consortii di bonifica of Emilia-Romagna. Here you see the map, in this map, the areas involved in the service. The first area is Consortio di Bonifica of Burana, that is the plain close to the Modena city, and the other areas is in Romagna. So this is the Consortio di Bonifica of Romagna. You see these areas are different. One is located in the plain area close to the Po River, the other one is close to the sea. The other map that you see below the colored polygons that represent the early crop map, so the light blue map represents the soil map. That is, it contains crucial information on the main features of soils that is used as input for the model to compute the soil water balance. The third map that you see below is a grid. This is the gridded weather data that are available for all the Emilia-Romagna, and the data, the weather data needed by the water balance are daily temperature and precipitation data. So early crop map, soil map, gridded weather data, and forecast, so seasonal and 7-day forecast, are the input data for the criteria water balance model. Criteria that mentioned Vittorio is a free code available on GitHub. These are the slide about the input of WRI. Here we have a slide about the format of the output. Output can be are provided to the users via a GIS web app. We will go through this part in the next slide, or the user can download the data from FTP folder, and the data can be provided as a CSV file or as a shape file. Now let's see the interface, the GIS interface that we have developed within the Esri Italia for WRI. This is a typical GIS interface, GIS web app that allows the user to browse data in space and time. The user can gross data in space because there are the typical tools like the zoom or the pen to move in space. But there is also a time slider that allows the user to go back and forward to check to see the data. This is a rather interesting and useful tool for the maps, so the user can see the forecast through time. Then all the maps are listed, are listed in this window, and we can see that there are the first group, the first type of forecast, of irrigation forecast, the seasonal irrigation forecast, and then the group of the 7 days forecast, so irrigation forecast, crop evapotranspiration 7-day forecast, precipitation forecast, and another interesting product that is the previous irrigation assessment. So the user can have the assessment of irrigation for the crops from the first day of the irrigation season to the day of interest. Here you can see the early crop map, and this map, each map listed in the window have a legend. For the early crop map, this is the early crop map of 2019, of this summer, for Consorte di Bonifica Murana Modena. You see a legend. In this case, you see a quantitative legend, so each color corresponds to the crop classification, to the crop, whereas for the maps you will have a quantitative legend. Then you see also some tools to perform a statistical analysis or to display time plots that we will see in the following slides. Now, I will describe in the following slides the products. Here again, the early crop map for this summer, but obtained for the Consorzio della Romagna, Consorzio di Bonifica della Romagna, and with the corresponding legend. The map, as I told you before, is available in April, so we can perform the seasonal forecast since the beginning of irrigation season. And here we can see the seasonal probabilistic forecast for the Consorzio di Bonifica della Romagna. This is a map of the forecast for the 3-month period, May, June, July. The result of the seasonal irrigation forecast are expressed as anomaly of seasonal irrigation forecast with respect to the climate. It means that if the anomaly is positive, the delta is positive, so the prevailing color on the map is red, it means that the crops for the 3-month period will need more water than the climate, the climate of irrigation, or let's say the mean irrigation of the past years. Where on the contrary, if the anomaly is negative, it means that the crop, so the forecast is saying that the crops will need less water than the climate of irrigation. In this forecast for the May, June, July 2019, you see that the prevailing color is white, but we have a part of the map colored in red. This is an interesting information because in this part of the area of Consorzio di Bonifica della Romagna, we have orchards. So the basic information of this map is the forecast, the seasonal forecast for May, June, July will be close to the climate value, but with positive anomalies. And it is this map, this information about the seasonal forecast is realistic because we have two heat waves in June and July 2019. Okay, now let's skip to the 7-day forecast products. Here you see a basic information and simple information that we provide, that WRI provides, but it's crucial for the water manager. So the precipitation forecast. The service provided the map of the 7-day precipitation forecast. This is a map taken last year, 2018, for the Burana Consortio di Bonifica. And here you see that this dark blue refers to forecast that reached also 50 millimeters. This forecast was correct because in some areas precipitation of also 60 millimeters were recorded. As a consequence, we have 7-day precipitation forecast. As a consequence, we have also the map of 7-day irrigation forecast. This is the map of irrigation forecast related to the period of the precipitation forecast. So the irrigation is close to zero. This is another map taken this summer. This is referred to the Romagna area. And here you see the area with the orchards that I mentioned before. This is the 7-day irrigation forecast that referred to the 21st of July 2019. And here you see that in some areas we have the color ranges from yellow to red. So a quite rather high forecast of irrigation. The red polygons reached also 50 millimeters of irrigation, and they are typically the kiwi fruit, because kiwi fruit is one of the most water demanding crop for the area. One option that the user can have is to click on a polygon and to display a graph, a plot on time. And here, this is a plot of kiwi fruit in the area that we saw just before. And in this plot, you see that there are the trend of precipitation forecast, the blue line. The green line represents the crop evapotranspiration, whereas the orange line represents the irrigation forecast. And here, the map of the 21st of July this forecast can be visualized also as a time plot. This red circle represents the forecast of the 21st of July and represents also the 3 heat waves that occurred during 2019. So the high forecast of irrigation for the 21st of July was correct because on the 24th of July a heat wave occurred. We have used the WRI also to compare 2 different summers, 2019 versus 2019. Here you see the time plot that plots that refer to PIR for Consortio di Bonifica Burana, so the northern Consortio di Bonifica. And here you see how different are the summers. So if the irrigation in 2018 started at the end of May, during 2019 the irrigation started at the half of June, because a lot of precipitation occurred during the beginning, the end of May, and the soil moisture was very high. And here you see also the different trend of drought period, because in 2019 we have 3 heat waves that we saw also in the other time plot, but whereas during 2018, we had only one heat wave, but at the end of July, but for a long period. So, in conclusion, WRI can be used by water managers in agriculture for the forecast and the management of water for irrigation. It can be used also as an analysis tool for the assessment of crop water need ex post, so after the irrigation season. And our work, so the experimental part of WRI is ended with this summer, and we are working on the setup of a prototype on all the consorzi di bonifica of Emilia-Romagna within our internal system of Arpae IT system, hopefully for the next spring. So thank you.
Okay, thank you, Giulia. I would like to stress also that for this service, it is very important to rely on the weather forecasts and the seasonal forecasts provided by our colleagues who do this job. Especially, I would like to mention Dr. Valentina Pavan, who is providing us with the forecasts every month, and also would like to stress that the ECMWF, the European Center for Medium Range Weather Forecast, is helping us in providing the needed data and forecasts. So it is a teamwork relying on many specialists, and so I would like to say that without such a large team, it would be impossible to develop such complex services. All we see at the moment that there are about 17 participants. I would like to stress that they can ask questions. There is a specific way to use the board to make questions, and I think we will have at the end, after Stefano's presentation, a moment to discuss questions and issues that will be raised by our listeners. So it's now time to move to the second climate service that will be presented by Stefano Bagli. Again, I say from the private company GECOSistema. And the GECOSistema developed this climate smart irrigation tool called irriclime. What you see now on the screen, Stefano put on the screen the leaflet describing this climate service. For all 14 climate services of the Clara project, we developed and updated similar leaflets that can be downloaded also from the Clara project website. So Stefano, it's up to you now, and I leave the floor to you. Thank you.
Thank you, Vittorio, for the presentation. Thank you, everybody, for being here today for this webinar. Just a quick presentation of myself. My name is Stefano Bagli. I'm one of the founder, together with Paolo Mazzoli of GECOSistema, an environmental engineering company based in Italy. We are involved with Arpae in the Clara project. And today I will present irriclime, climate smart irrigation tool that is a climate service focused on irrigation. You will see a lot of similarity with the previous climate service presented by Giulia, but you will also notice some peculiarities and some difference. So why, first of all, why we decided to develop a climate service for irrigation? So first of all, we have the climate change that treats in multiple ways the agriculture. So for example, we have threats related to water availability for irrigation and also for sustainable management of natural resources.
And this reflects in a loss of farmer income and agricultural productivity. Climate can also threat agriculture in terms of crop disease. The focus of IRRICLIME is more is related to the irrigation part and also the evaluation in terms of guarantee the agricultural productivity and the farmer income. So if from one side we have the threats posed by climate change, in the other side we have different opportunity related to develop climate services. In particular, the increasing available of, for example, climate data and models that are made available, for example, by the Copernicus platform. And we have also space data that can be useful to be exploited in climate services. We have crop and hydro balance water models. We have also artificial intelligence and machine learning approaches that can be useful. And finally, data that can be collected through the Internet of Things, the IoT. So all of these tools and data can be embedded together in climate services that we are now developing in the Clara project, and can be and the value and the information that can be developed and can be deployed to the end user, that could be farmers or irrigation authority, with the purpose to improve the efficient and the sustainable use of water resources, to support the farming practices and also support mitigation and adaptation measures in agriculture. So how we decide to develop IRRICLIME? First of all, we embed into a cloud web platform. So IRRICLIME is a cloud web application that can be accessible through web browsers. And so we embedded into IRRICLIME the Copernicus seasonal and long-term forecast made available by the climate data stores. So as you know, the climate data store can provide for free, without any limitation, data related to seasonal forecast and long-term climate projection. The second element of IRRICLIME is represented by local meteorological observation that are very important in order to apply the bias correction and the downscaling at the requested spatial resolution. So inside the IRRICLIME, we have implemented all the bias correction and downscaling algorithm. The third element is represented by the crop soil water budget model. As Giulia mentioned, we use the same model, the criteria 1D developed by Arpae, by Vittorio. But we also implemented a simplified indicator that is called BIC, that is simply a water balance made by subtracting to the precipitation, the evapotranspiration, plus the irrigation available in the field. Finally, we have information about the crops. So this is the same maps that we've seen before. So the crops maps are available in the area of where we have implemented the service, with all the phenology characteristics. And then we need information about the network data. So we collect directly from the irrigation authority all the characteristics of the irrigation network. And finally, what we have done in developing IRRICLIME was to work together in tight connection with our end users. And our end users is represented by the Consorzio di Bonifica della Romagna, the Land Reclamation Irrigation Authority of South Romagna. And so we work with them, we collect the user requirements, and we try to tailor the IRRICLIME service based on the user needs. In particular, the Irrigation Authority of Romagna region. So this is the framework, the final framework of the IRRICLIME services. So as you can see, we download directly from Copernicus through the API that are made available by the CDS. We download the seasonal long-term forecast. We download the on-site meteorological data provided by the Consorzio di Bonifica, and then we upload all the data automatically to our database that is in the cloud framework. And then we have the downscaling procedures and the crop soil water balance predictor that are published in the web server through the web application. So actually, we are also integrating in the system several IoT sensors, in particular, what we need for computing a correct water balance is the soil moisture in order to initialize the computation of the cumulative water balance. So we have integrated 2 sensors provided by the consortium that collect in real time in a daily base and send the soil moisture data to the database. But for example, we can also integrate other data related to crops, for example. So what is the main purpose of irriclime? So irriclime provide prediction in terms of maps and plots of seasonal forecasts for crop soil specific water irrigation needs, and climate forecast for the same needs, the irrigation amount. So the target users are the farmers, the single farmer, but are also the irrigation authorities, and could be also extended to insurance companies. The idea is to support decision in water procurement, in assessing which is the water balance for each irrigation district, evaluate which is the increase of efficiency in terms of reduction of climate impacts, in particular with the purpose to save the harvesting and the incomes for the farmers, select which is the best mitigation adaptation option, and also contribute in manage in sustainable manner the water resources. So this is a list of answers that we have collected from our end users, and we identify as potential irriclime can provide potential answer to all these questions that are more or less related what I have presented before. So which are the main outputs? So irriclime can provide cumulative or cumulative calculation of the soil water budget specific for each crop and soil, and also specific for the irrigation amount that is available. And we compute this calculation every 10 days of aggregation, and we can plot different variables. So the main variable is the soil water content, but we can plot evapotranspiration, all the variable involved in the calculation of the water balance. A second output is represented by a climatic web bulletin that will be used and disseminated by the Consorzio di Bonifica through all the farmers. And the idea is to provide tips in terms of irrigation related to seasonal risk and climatic long-term risk. So the bulletin will be developed in the web application. So it will be a web bulletin that can be disseminated to all the farmers of the consortium. So the business model that we are thinking about here, irriclime, we are thinking about 2 different business models. One is to sell irriclime as an enterprise solution for irrigation authorities with an installation fee and an annual subscription. But for the single farmer, we are thinking about a cloud web SaaS software as a service platform, where the single farmer can access to the platform and pay a monthly or an annual subscription. Okay, so this is the main interface. I will try to make an online demo. I hope that I'll be lucky. So the demo is available at this website, GECOSistema.com/irriclime. This is the first beta version. We are working in a version 2.0 that will be available soon, before the end of this year. So if you go to this web address, and then you will get this redirection, but the others is correct. So this is the first interface. You have the layers, and so our study area is located in the south of Emilia-Romagna. You can see the station, the meteorological station, where we collect all the on-site meteorological data. And then we have the height basins that are the units, the meteorological, the hydrological units, where the climate data store provide us the results, the forecast, the seasonal forecast, and the climate change forecast. And then if we zoom a little bit, we have all the irrigation districts in the area of interest. So the user can play with the interface and obtain different prediction. The first kind of prediction are related to climate change scenario. So can select multiple crops. In this case, we select actinidia, that is kiwi, and can perform multiple climate change scenario that are made available in Copernicus. We have different RCP. So in this case, we can plot, for example, the year 2050, and we can decide to plot the accumulated value of soil water content and plot the ensemble of all the model. The user can edit the irrigation capacity, and so in this case we decide to have 10 millimeters of irrigation capacity in field, available in field at the crop every 10 days, and then can also update the KC parameter, the crop coefficient, in order to correct the evapotranspiration. And once I've inserted all the input, can compute the water balance in climate change scenario. For example, this is for the Castiglione, and you can see the cumulative value of soil moisture that is available in a typical year in a climate change scenario, considering the ensemble and the time of projection is 2050. You can see that after the 17th of July, we will have some problems in terms of we are below the specific threshold, so it means that we will have a loss of harvesting. So the user can play multiple scenario, means that it can, for example, change the irrigation amount. For example, if we increase the irrigation amount that we are available, for example, adopting a better irrigation system, for example, 30 millimeters, then can rerun the calculation in the station of interest. And you will see that the cumulative value is above the thresholds, and so in this case we will not have any loss of harvesting. So the other kind of services related to the seasonal forecast here are implemented the in-cast data, but in the next month the service will be operative in sense that the seasonal forecast will be collected automatically, and so the service could be used as operative. So for example, we can plot we are in 2004, we can plot the hintcast that are available in the database. For example, we are in May at the beginning of the irrigation season, and we can run the model and again check which is the cumulative value of soil water balance. In this case, we start from 0 because we don't have any information, but we will see, we notice that we have a decrease below 0 of the amount of water available for the crop. So in this case, we could have some risk in terms of loss harvesting. So the user can play again with the KC, with the irrigation amount, and run the model in multiple scenarios. So respect the service that we have seen before, we have some difference. In this case, the user can play and can insert different input and can evaluate under multiple scenarios, which are the forecast in seasonal and in climate change scenario. We have also implemented the calculation using the criteria 1D. And so that's all for the demo. I will go back to the slide. So my last slides are related to an exercise, to present an exercise that we have done together with the colleague of CMCC. The idea was to assess the economic value of the information associated to the IRRICLIME, to the information provided by the climate services. So we have done this exercise in a climate change scenario, and we have computed that the information provided to the user can be assessed in terms of economic value. And in the case of the Castiglione district, that is a small irrigation district in the study area, the values are around 92,000 euro per year. So this is quite relevant and is quite useful in order to disseminate the importance of the use of climate services among the irrigation authority. And so I think I will quite out of the time. These are the conclusions. So the IRRICLIME service is supporting now Regione Romagna Irrigation Authority and is providing the seasonal and long-term agroclimatic web bulletin. The idea is to anticipate the mitigation measures at the beginning and during the irrigation season. The idea is to inform the agricultural companies and the single farmer about the dangers and economic damages that could be caused by irrigation resource shortage, and also to support both farmer and the irrigation authority in selecting the best mitigation measures in terms of irrigation efficiencies, but also in terms of, for example, supporting less hydro-demanding crops. For the future development, we are working more integration of IoT, and also working in developing a more personalized and tailored version for single farmers. So that's all for my side. Thank you, and if you have questions, I'm remain available.
Okay, thank you very much, Stefano, for your complete and very interesting presentation on the IRRICLIME climate service developed within the CLARA project. You stressed also the importance of the Copernicus system, where we are getting data, satellite images, weather forecasts, seasonal forecasts. All the services rely in a way or another to the Copernicus European system of climate monitoring from space. It's time now for our participants, if they like to write questions for you or for Giulia. And there is on the dashboard, there is the possibility to write questions or to raise your hand and to say something, to write or comments or questions on the presentations you had on this subject. I have a question for Stefano. If in the meantime, while our public is listening, and I would like to ask Stefano, do you think it is possible to easily move your climate service also to other areas? Because you mentioned that the consortium is providing you with weather data and so on. So in the perspective of going, say, to the market, how easy it would be to develop this type of service for other customers, say in other corners of Italy or Europe?
Yes, the idea now is after they have developed this prototype focused on specific areas to extend and to generalize the service. So I think the Copernicus climate data stores can provide us the seasonal and long-term forecast for all the world, more or less. And related to the downscaling bias correction, we need also local data. So this is the tricky point. We should also be able to collect data of real data. And so we have also, again, from Copernicus, the ERA 5 reanalysis data that could be exploited and integrated into the system, but we should also try to integrate different source of data in order to have a better downscaling procedure and bias correction. But yeah, theoretically, we can go worldwide soon.
Okay, thank you. Another question for Giulia is: can you describe a little bit the interaction we had with users, for instance, in the Modena Burana consortium, because the interaction was rather strong, and there was a good interest, and they also provided support data and so on.
Yes, I didn't mention this part of the work in the presentation, but yes, I will do in this now, because a very interesting part of the project was the co-development of WRI with the users. For instance, we had interesting discussions with the users. I think that we had a very fruitful discussion, because they learned what are about a climate service, for instance. First, information, basic and simple, but very important. And then we had other discussions about, for instance, the crops, because each test areas has its peculiarities about crop features. So we had a more detailed information on the crop cycles or the irrigation methodologies, and this is very useful to provide a better information, or more useful information for the users. And then we had also I think surprising, interesting discussion about the assessment of our data, because this kind of data, observed data of irrigation on Consortia di Bonifica, are quite rare to find, and so we have found this data on irrigated districts that are monitored by means of devices, and so we had the chance to check our forecast with observed data. In 2018, we had the first contact, so a first analysis, a first year of trial, let's say. 2018, we had added to our modeling system the information of the consortia, and the check of observed data with our forecast resulted better than the previous year. So I think that this co-development mechanism is very useful.
Okay, thank you. I don't see questions from, oh no, there is one question maybe. What is, well, I need some, I have to I have problems in reading the questions, because it is a very tiny corner of my screen. Sorry.
Vittorio, if you want, I can read the question.
Yes, please, because I cannot.
Sure.
I can read only a few words of them.
Yeah, sure.
Yes, please.
So I'll just read it. What is the possibility of supporting and financing this model in the third world countries such as Palestine, Jordan, Lebanon, due to the water shortage and scarcity and water quality problems through NGOs and scientific research centers? And then Shadi, this is the question is being posed by Shadi El Abash, and he adds, I have more than 7 years of experience managing projects founded by international funding related to enhance food security, water services, climate change adaptation and mitigation in the poor rural areas, which are farming areas, open farm and greenhouses. So the original question was, what is the possibility of supporting and financing this model in the third world countries?
Well, this is a rather difficult question, I may say, and it's something that we could place directly to the coordinator of the project, because Jaro Misiak from CMCC designed this project and he's managing it, and for sure there are connections between this project and other projects that are being developed where to transfer climate services to areas which are in the Mediterranean and out of the strictly European context where we developed the Clara services. So what I suggest to our friend making the question is to put this question by email directly to CMCC. Maybe Ottavia can provide again our email in order to write
yes,
questions directly to the because this
yes.
is, I think, a very interesting question, how to move from outside Europe into the Mediterranean and how to move into areas where there are problems with water and with finance, of course. I would like to stress that WRI system is going to be released for free as a freely available service at the scale of the water irrigation areas, not directly to farmers, but again to authorities distributing and providing water to farmers, as we are a public agency from the region of Emilia-Romagna. But in case of, let's say, commercial services, like, for instance, what is IRRICLIME is going to, maybe a short comment would come from Stefano.
Yes, our idea is to try to sell our services to potential customer. It could be farmer or irrigation authority. So from the technological point of view, I think it will be that there is no any issues related to developing in the third world, I don't know, in the south of Europe or in Africa, in North Africa. We don't have any.
In the Middle East.
In the Middle East, yes. So from the technological point of view, there is no any limitation related to the financial aspect. We could speak how to work together in a research project, in a development project with the NGO or other company or institute. We are available for that.
Okay. Okay, thank you very much. Also, if there are no other questions, I would like to thank again for CMCC for organizing the webinar, and our colleagues Giulia Villani and Stefano Bagli for providing very clear and well organized presentations. And again, I would like to stress that the next Tuesday, same time, there will be another webinar devoted to climate services for energy, again coming from the Clara European project. So thank you everybody, and see you in the coming weeks.